use row operations to transform the matrix to reduced row echelon form. So reduced row echelon form, the first row needs a leading 1, which we have, and in that column there should be everything else zeros, so we need to get that to be a 0. What we can do is row 1 plus row 3. Row 1 plus row 3. And that will be our new row 3 when we're done. So row 1, 1, negative 1, 1, negative 1, plus row 3, negative 1, 1, 1, 1. Adding these together, we get 0, 0, 2, 0. This equation, and yes, it is an equation, it's z equals 0, 2z equals 0, can be simplified. Anytime there's a common multiple in your numbers, divide by that. Sorry, I said common multiple. A common factor, the greatest common factor, divide by that. And you can simplify the equation. 0, 0, 1, 0. Again, that's our new row 3. Matrices always have to be in the matrix bracket. We have our original row 1. It had the 1 where we wanted it. Row 2 had a 0 already in place where we wanted it. And now we have a new row 3 with the 0 where we were trying. And we got a bunch more zeros as well. Okay. Next up, our second row needs a leading 1, which we have it, and its column needs to be cleaned up, so we need to make a 0 there. We can just do row 2 plus row 1, and that will make the 0 in the row 1 equals row 1. So row 2, 0, 1, negative 1, negative 1, and row 1, 1, negative 1, 1, negative 1. Adding these up, we get 1, 0, 0, negative 2. 1 prime number, we can't reduce this any further. This is row 1. We now have 1, 0, 0, negative 2, 0, 1, negative 1, negative 1, and our row 3, 0, 0, 1, 0. Looking better. Notice when we do a row operation where we add 2 rows together, the result can replace one of the original 2 rows that you added, but only one. So out of the 2 rows, you'll have an original and a new one after you're done. That's why we're only replacing one of our answers with these results. Everything else is staying the same. Okay, last thing. Our third row needs a leading 1, which it has, and its column needs to be cleaned up. We need a 0 there. And that's a simple row 3 plus row 2 will give us a new row 2. So we have row 3, row 2, added together, 0, 1, 0, negative 1. This is our new row 2. And this only replaces the row 2. The row 1 stays the same. We have this row 2, and row 3 stays the same. Now let's double check the instructions. Our instructions are to transform the matrix to reduced row echelon form. Therefore, this is the final answer. It's also telling us that negative 2, negative 1, 0 is the solution, but we weren't trying to find the solution. We were trying to get to reduced row echelon form. Okay.